Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is implicit differentiation. In this video, we are going to discuss the process of implicit differentiation. Before starting with this video, let us have a small recap on explicit functions. So what are explicit functions? For example, please consider this function y is equal to 3x plus 1. The value of y is dependent on the value of x. X is the independent variable here. For every x value, we can easily find its corresponding y value just by substituting and simplifying. Am I right? For example, let me take some values for x. Let me assume some just random values. X is equal to 0, x is equal to -1, x is equal to +1. Let us find the corresponding y value when x is equal to 0. If you substitute x by 0, you'll be getting y equal to 1. Am I right? Same way, you can also find the values of y for x is equal to -1 and x is equal to 1. Therefore, our point on the graph would be 0, 1, -1, -2, 1, 4. However, some functions y are written implicitly as functions of x. In other words, the function is written in terms of x and y. In these cases, we have to do some work to find the corresponding y value for each given x. Okay, let me take one example of an implicit function. Here is an example. Did you notice that this function is written in terms of x and y, unlike the previous example? So, to find the y value, in the same concept, let me apply the same concept as I did before. I'm going to assume some x value. Okay, let x be 1/2. So how can we find the y value? First, we have to plug in this x value in this equation and then solve for y as usual. So if I do so, this is 1/4. Subtracting 1/4 from both these sides. I want to get rid of the square, so I'm taking square root on both these sides. So I'll get. Hope you're clear with these steps. Thus, with a little bit of algebraic manipulation, we found the point. When x is equal to 1/2, y is plus or minus √3/2. So this can be written in pairs like this. Hope you're clear with what is meant by implicit and explicit function. Okay. Let us see the process of implicit differentiation. There are few methods to find the implicit differentiation. Now I'm going to use the chain rule and show you step by step. Since implicit functions are given in terms of x and y, deriving with respect to x involves the application of the chain rule. Am I right? Okay, let me take the same function. Here is the example, x square plus y square equal to 1. We are supposed to find dy over dx, which is equivalently we can say y dash. Okay, let us start with step 1. Multiply both the sides of the function by d over dx. You can take this within the parenthesis. I mean, you can write d over dx for each and every term on the left side. Now next step, let us differentiate x square and 1 with respect to x. Hope you all know the basics of differentiation. For more detailed information about the differentiation, you can refer our previous video on the topic differentiation. So derivative of x square is 2x and this one, a constant, is always 0. Please notice that we cannot differentiate y square with respect to x as these, because this would be written in terms of y. So let's perform the chain rule on this one. D over dx y square. First, differentiate y square with respect to y and then multiply the result by dy over dx. Hope you are clear till this step. Please remember, our goal is to solve for dy over dx. Okay, now let us isolate this dy over dx on the left side and shift all the other terms to the right side of the equation. Subtracting 2x from both these sides and dividing both these sides by 2y, we will get. That's it. Hope you are clear with this example. Okay, so we have to start multiple both the sides of the function. Whatever function is given, start by multiplying both the sides of the function by d over dx and then split it according to the sign given. And differentiate all the other terms with respect to x except the y terms. Then you can apply the chain rule to differentiate the y term and isolate dy over dx on the left side and shift all the other terms to the other side of the equation. That's it. This is how you have to do the implicit differentiation. Let me take one more example, somewhat different from this one. Here is a function given x y cube plus 4x square minus 3x is equal to 5. By looking at the function itself, you can understand that this is an implicit function because it is written in the terms of x as well as y. And here our goal is to find the expression for dy over dx. So let's start with multiplying both the sides of the function by d over dx. It is not necessary that one side of the equation should be a constant. Examples what I am taking is we have a constant on the right side of the equation. You may also get questions with variables on the right side like x and y. Okay. So whatever the function may be, process is same. You have to multiply both the sides of the function by dy over dx. Differentiate all the other terms with respect to x except this y term. Wherever y terms come, you can apply chain rule. There is also one more method to find the implicit differentiation. We will talk about that in our next video. So here we are focusing on the implicit differentiation using chain rule only. Okay, let's start with the solution. Multiply both the sides of the function by d over dx. According to the rule of sum and subtraction, we are going to take this within the parenthesis. We are going to find d over dx for each and every term within the parenthesis on the left side of the equation. Now differentiate 4x square and 3x and 5 with respect to x. Derivative of any constant would be always equal to 0. So the right side would be equal to 0. Now this would be, you have to take the constant out and apply the power rule. Here you have to take the constant out and apply the rule for a variable. Okay, so this would become, we didn't apply d over dx for the y term. We cannot differentiate x y cube with respect to x alone since y is in this term. Okay, hope you're clear till this step. Now let's perform the product rule between the functions x and y cube with respect to x. Hope you remember the product rule. In case if you have any query regarding the product rule application, you can refer our video on product rule and its application. Now here we are going to apply product rule and between these terms, I mean the variables x and y cube with respect to x. Product rule is nothing but the derivative of the first term times second term plus derivative of second term times first term with plus sign in between. Hope you are clear till this step. So where possible, derive with respect to x. Here this would become 1 times y cube plus x times y cube d over dx. Okay, here is where we are going to apply chain rule. Now let's apply the chain rule to y cube d over dx by differentiating y cube with respect to y and multiplying the result by dy over dx. Please remember that our goal is to solve for dy over dx. Okay, so we will get, I'm showing only this part here. We are just applying chain rule here. Hope you're clear till this step. Now dy cube over dy, this is 3y square. Am I right? Now substitute this in our found values into the first expression which we got before. Just plug in the values, the expression we got in this place. So we will get, now let us solve for dy over dx. So first I'm going to shift 3 to the right side by adding 3 on both these sides and subtract 8x from both these sides. So it will be vanished from the left side of the equation. It will be shifted to the right side. Same way, subtract y cube from both the sides of the equation and then divide the entire equation throughout by the coefficient of dy over dx. Adding 3 on both these sides, subtracting 8x and y cube from both the sides of the equation, we get this. Now divide the entire equation throughout by 3xy square or 3y square x. And that's it for this example. Our goal is to isolate dy over dx on one side of the equation and shift all the other terms to the other side of the equation. Once you have a good idea of how the chain rule works, you may begin to skip the steps. You can make it short. Initially, until you get practice, you just do step by step. You don't skip any step. Sometimes you may get questioned that why can't we use normal differentiation here? The problem is we will be getting plus or minus sign if you are isolating y on one side of the equation for the function given. So with this in the solution for y, we see that y is in fact two different functions. So we might get a question, which should we use? Should we use both? We only want a single function for the derivative, and at best we have two functions here. So that's the reason we prefer implicit differentiation rather than normal differentiation. Just to avoid the confusion which solution would be the right one, we always prefer implicit differentiation wherever y cannot be isolated, whenever the function is in both the terms x and y. So this is all about implicit differentiation using chain rule. In case if you have any query regarding this video, kindly let me know. See you.